All right, let's talk about one of the most fundamental and honestly one of the most confusing parts of JavaScript, the prototype property. It's the real engine behind how inheritance works, but just the name itself trips so many people up. So today, we're going to dive in and get this cleared up once and for all. And this is it. This is the big question, right? The heart of all the confusion. You've probably seen F.prototype. It's just a regular property you can see and touch. But then there's this weird double bracket prototype thing. They sound almost the same, but they do completely different jobs. So let's break it down. So here's our game plan. We'll kick things off by making sure we know the difference between the two prototypes. Then we'll uncover how the new operator is the secret sauce that connects them. We'll look at the default constructor property you get for free, see the super common way it breaks, learn how to fix it, and then wrap it all up. Sound good? Let's do it. Okay, first things first. Before we go any farther, you have to get this one idea straight in your head because literally everything else we talk about builds on this. We are talking about two totally different things, even though their names are ridiculously similar. So check this out. On the left, F.prototype. It's just a normal property that lives on a function. That's it. Think of it as a blueprint. Its one and only purpose in life is to be used when you create a new object with the new keyword. Now on the right, you've got triple prototype. That is the real deal. It's a hidden internal link on an object that points to its parent. It's the actual chain of inheritance. So one's the blueprint, the other is the actual connection. So how exactly does that blueprint, F.prototype, create the actual inheritance link, the triple prototype? Well, the magic all happens thanks to one little operator, new. It's the bridge that connects these two worlds. Let's build this out with an example. First up, we've got a super simple object. We'll call it animal, and it has one property. Eats is true. This guy is going to be the ancestor, the parent in our little family tree. Next, we need a factory, right? A way to stamp out new objects. So we'll create a constructor function called rabbit. Its job is to build our rabbits. And boom, this right here, this is the magic line. This is the single most important piece of the puzzle. We are telling our rabbit function, hey, that blueprint property you have, I want you to make it point directly to our animal object. That's the setup. So what does this line actually tell the JavaScript engine? It's like leaving a set of instructions. It says, hey, listen up. From now on, anytime someone uses new rabbit to make an object, I want you to take that brand new object and forge a secret internal prototype link from it back to this animal object. So we run the code and create a new rabbit. Now, two things are true at the same time. Our new rabbit instance has that hidden double quotation prototype link pointing to animal. And our rabbit function still has its public.prototype property pointing to that same animal object. The new operator has read the blueprint and made the connection, just like we asked. I absolutely love this way of thinking about it. That prototype link is a one-time gift. It's given to the object the moment it's created, and it's permanent. If you come along later and change rabbit.prototype to point to something totally different, our existing rabbit doesn't care one bit. It already got its gift. Only brand new rabbits made after the change will get the new prototype. Okay, so that's how you can set a prototype yourself. But what happens if you, well, don't do anything? Turns out JavaScript is pretty helpful and gives you a little something for free right out of the box. Here's the deal. The moment you create any function in JavaScript, it automatically gets a .prototype property. And that property is an object that contains just one thing, another property called constructor, which is a reference that points right back to the function itself. It's this handy little circular reference. So why on earth is that useful? Well, imagine you get an object, rabbit, from somewhere else in your code. You have no idea it was made with the rabbit function, but you want to make another one just like it. Well, you can. You can just access rabbit.constructor to get back to the original function and create a new instance. It's a really flexible pattern. Now for the twist. That super helpful constructor property we were just admiring, it is incredibly easy to break. And this right here is probably the #1 most common mistake people make when they're working directly with prototypes. Look closely at this code. Instead of adding properties to the default user.prototype, we have completely replaced it. We've just assigned it to a new empty object. That freebie constructor user object that JavaScript gave us, yeah, we just threw it in the trash. This is the mistake. So here's the puzzle. We make that mistake, then we create a user. And just like before, we try to use user.constructor to create a second user. But when we check user2.name, It's undefined. It didn't work. Why not? What went wrong? Let's trace the steps just like JavaScript does. It looks for constructor on the user object itself. Not there? Okay. It follows the __ prototype link up to user prototype. But wait, we replaced that with an empty object, so it's not there either. No problem, JavaScript keeps going up the chain all the way to the base object prototype, and aha, that object has a constructor property, but which one? It's the main built-in object function. So our code ended up running new object, not new user, and that's why user2 doesn't have a .name. So that's the trap. But the good news is, once you see it, the fix is actually really simple. There are two main ways to correctly add things to a prototype without breaking that all-important constructor link. On the left, we have the safest and simplest method. Just don't replace the prototype. Add your properties one at a time. This way, you never touch the original object, and the constructor property is safe. Now on the right, if you really want to replace the whole object, maybe for organization, that's fine. You just have to remember to manually add the constructor property back yourself, pointing it to the right function. Both ways work perfectly. Alright, we've covered a lot, so let's take a second and just boil it all down to the absolute essential rules that you need to take away from this. Here's the bottom line. F's prototype is the blueprint on a function. It's only used by the new operator to set up the real hidden double prototype link. And remember the big trap. Wiping out the entire prototype gets rid of the default .constructor property, so always make sure that property is set correctly to avoid some really weird bugs. And that brings us to a final interesting thought. Everything we just looked at is the raw engine of JavaScript's inheritance. Modern class syntax is really just a cleaner, nicer looking way to do all of this same stuff. So it leaves us with a question. Now that you understand how the machine actually works under the hood, when should you use this raw power of prototypes? And when is it better to just reach for the simpler class syntax? Something to think about. Thanks for joining this explainer.